Awesome. Hi, I'm Brook Constantz. I'm a PhD student in the whole Restoration Ecology Lab at UC Santa Cruz, and I'm going to be talking about the environmental aesthetics of habitat heterogeneity. So just to jump into it, most restoration projects focus on mostly on ecological outcomes, but they could benefit from thinking more about social outcomes. One way to improve social outcomes is to engage stakeholders, and stakeholders being in this project like anyone that is affected by a restoration project, not necessarily the planners or practitioners. But if there's a mismatch between what the stakeholders in a community expect and how the restoration project ultimately ends up, there can be kind of consequences for restoration. It can delay timelines, it can make the project cost more, and occasionally it can stop the project. And stakeholders usually care more, but not always. Usually they care more about how project looks. That's how they see success, rather than the specific ecological details, like what tree species were planted where. So this is where heterogeneity enters. So heterogeneity, most simply, describes landscape complexity. Most restorations, or many restoration projects, could benefit from more habitat heterogeneity, as often they're planted on disturbed sites that have been homogenized. Think like old abandoned farmland. Habitat heterogeneity often links to the visual aesthetics of a landscape. So what I'm asking with this study and the survey I put together is, when does increased habitat heterogeneity also align with increased preference by stakeholders, like, for example, more visual beauty, which would improve acceptance? So to get at this question, I created a visual survey in Unreal Engine, which is a popular game engine right now. And I streamed it online, where up to 5 people could take it at a time. And you could rotate the landscapes and zoom in and out. And what I did is I collected a bunch of field data for tree positions, tree species, diameter, breast height, understory cover, and I would simulate it. And so what I could do with that, because I had created a GIS, is I could modify one of those levels. And in this example, I have like a high understory cover, a high understory complexity, and this is like more of a mode site with low understory complexity. I also created young restored sites, because that's an easier place to implement habitat heterogeneity. And in this example, I have more of island nucleation, and then these are just standard rows. And I tried to find models that looked most like tree species available along the Sacramento River, where this study takes place. I also had one more question where participants could build their own landscapes, and they had these slider bars where they could manipulate them, and the landscape would update in real time. And so I got 110 respondents. Thank you for the people in this room that took this survey. 85 of them are within 25 miles of the Sacramento River, so we're qualified. And I got 58 written responses that I thematically coded to look for themes and why people were picking their preferences. Based on people's predominant land use, I either classify them as utilitarian or biocentric. So to jump into the results, and I'll quickly talk about the axes. So on your y-axis, you have a proportion of the time that you picked high heterogeneity when you were given a question. So each question had either high or low, and they picked high. So the higher the value is, on average, the more that group picked high heterogeneity, or they preferred it. So for how flat the landscape was, you find that utilitarian people prefer flatter landscapes, especially in young restored forests, versus biocentric people. And that could relate to just young restored sites have smaller trees, so it's easier to see the topography. It's more visible. If you look at variability in tree size, so a very variable site would have trees that are both small and large, where a more homogeneous site would have trees all of the same size, like an orchard. You find a very strong signal definitely with young restored forests, especially because, once again, there's small trees. So a large tree in a forest of small trees is really obvious, but it's fairly intermediate even with utilitarian, and it kind of drops off with older restored and reference forests. And if you look at understory complexity, you find that it's fairly intermediate with utilitarian folks and somewhat higher in both forests with biocentric stakeholders. As far as designing your own landscape, we found that biocentric people prefer more large woody debris and more understory complexity, and utilitarian folks are writing about, importance for fishing quality, hunting quality, ease of movement, which gets some of that lower understory complexity, where biocentric people focus more on visual complexity and recreation. So as far as implications for restoration, both groups seem to prefer variable tree size, especially in young restored forests. Topographic roughness, understory complexity, and larger weighted debris can be very contentious, so think about the people using the landscape before you implement it. And utilitarian folks prefer more of an intermediate level of heterogeneity, while biocentric people prefer a higher level. And I wanted to thank all my funders. So.